quick overview, the goal of this was to use sensors to grab information about the environment, and the information we want to grab is about the indoor air quality. And so I used a couple sensors, and I connected those to a microcontroller, an STM32 Nucleo, and yeah, kind of used I squared C to get information from both of the sensors, which are at different addresses, and then doing some processing on that. So I'll just quickly go over what the hardware itself looks like. We have a breadboard here, which has both of the sensors that I was talking about. This one here is the SGP30, and then this one right here is the SHT31. So the SHT31 is for temperature and humidity, and the SGP30 is kind of grabbing ECO2, so kind of the carbon dioxide in the air, and it's grabbing like volatile or organic compounds which contribute to air quality. We also have a few LEDs here, which are in series with our resistors. And again, we do have a STM32 Nucleo here, and that's connected via power to my laptop over here. So now what I'll do is I'll kind of show this in action. So I will share my screen. So the way that I've architected this is that we have the Nucleo, which whenever it's receiving power, it's going to send data over USART2. And so our Python service here will grab, and I can show you here real quick, our Python service over COM port 5 will create a serial device object here, and then it will talk to that device and read lines continually. So yeah, we have that, and then the Python service sends data over to our InfluxDB database. And so what we'll do is I'll show you that I kind of started the influx service here, and in the other terminal, I'm going to start the Python service. So we can see that the service has started. We have some logs here about configuration. We can also start the service with verbose mode, and so every single iteration will kind of get information about influx writes. It's going to get a little bit noisy, so instead of that, let's just start regular here. And then one other thing to kind of point out is if we disconnect the device, we'll see that I've kind of implemented some logic here to kind of check that the device is still connected. And then when it does reconnect, we'll see that we're successfully connected. And so what happens is that the Python service continually sends information, data to our influx DB. And what that kind of looks like here is that created a Grafana dashboard, which points basically at our influx DB. And so continually, it's just going to kind of look at this. Right now, I have it set to the last 5 minutes. We kind of look at data that I've had for the last few hours here, 12 hours or so. And so that's that. So what we'll do is I'll show you in action when we pass certain thresholds that I've defined. So what I'm going to do is I'm just going to breathe on this sensor here. So you can see that in our dashboards here, all this information is in red, right? And so that's part of that. I've defined some limits here for what is actually acceptable for safe at-home indoor air quality. And on top of that, what I've included is that these LEDs here will light up corresponding. So blue is data transfer. Green here is that our air quality is good. If I blow on it again, we'll see that it goes to red here. And so this is kind of a way here to kind of get information about the active air quality. And so this is an LED indication. We also have the Grafana indication here. And so this is my solution. Thanks.